In the last video, I covered many methods available to the linked list for adding and removing elements. Now I want to review the different ways to retrieve an element from a linked list. I'll add another method to this class. Private static void getting elements with a parameter linked list of string called list. I'll start by printing the element at index 4. This method simply retrieves the fifth element in the list and prints that out. Let's add a call to this method in the main method. First I'll comment out the call to the remove elements method. Call getting elements, passing places to visit. And now if I run this code, you can see we retrieved the element at index 4, which is the fifth city in our list, Sydney. I've said the get method is on both ArrayList and linked list. However, on ArrayList, the big O notation is O1 at its worst, whereas for a linked list, the worst case is ON. It's actually not as bad as that on a linked list. Since it's a double-ended queue, Java will decide where to start searching. The retriever will start moving from one link to the next, either from the start or the end of the list, whichever is closer to the specified index, so it would never traverse the entire number of elements. In addition to the get method, the linked list has the get first and get last methods. I'll print out the first and last elements using list.getFirst and list.getLast. Here we're calling each method and printing the result in the println statement. There should be no surprises when I run it. We get Alice Springs from the getFirst method and Toowoomba from the getLast method. We can also use the methods indexOf and lastIndexOf to see if an element is in a list, as we did with the array list. First I'll print the index of Darwin using list.indexOf. I'll now do it for Melbourne, this time using list.lastIndexOf. The big O notation is the same for these methods as it is for the array list. The worst case is ON for both, if the element retrieved is the element at the last position to be checked. Running this code tells us the positions of these towns in our list. As you can see, Darwin's at position 2 and Melbourne is at position 6. As you'd expect, linked list has additional methods for retrieving an element. The first is appropriately named element, which is a queue method. I'll print the result of a call to list.element. This method takes no arguments. What element does it return? Well, remember I've said it's a queue method, and a queue is first in, first out. So this should indicate that element gets the first item out of the list. Let's check the output. As you can see, we get confirmation of this because Alice Springs is returned. Now let's try out peak first and peak last, and print out the result of calling list.peak. Then I'll copy that statement and paste it. Change peak to peak first in both cases there. And I'll paste it again, changing peak to peak last in both cases. Time to run our code. And you can see that peak and peak first get the first element of the list, Alice Springs, and peak last gets the last element, Toowoomba. I've covered quite a few ways to add, remove and retrieve elements from a linked list. Let's switch gears and talk about traversing and manipulating the elements in the list. I'll start with a simple for loop. I'll say this list of towns is our itinerary and that we plan to travel to each town in the order I've defined here. I'll call the method printItineraries and pass it a linked list of string. I'll print out where the trip starts by call to list.getFirst and call list.getLast to see where the trip ends. This method uses the getFirst and getLast methods to print out the starting and ending points of our trip. I'll add a call to this from the main method after commenting out the call to getting elements. Call printItineraries passing places to visit. Running this code, we should see our list of places with the trip starting at Alice Springs and ending at Toowoomba. Let's include a loop to print the places in between and include an entry for each item except the starting and ending points. Every line item will include where we started and where we ended up. Traverse the entire linked list using list.size. Print where we start with a call to list.getPassingI -1 and where we are going to with a call to list.getPassingI. So this for loop starts at I equals 1 because we don't want to include an entry for the first town we started in since we've already printed that out. And then I'll print the item we started at using I-1 as the index to get that town, and then get the town at the current index. Let's see if we get the correct breakdown of towns. As you can see, we get a decent itinerary that looks good to me. I've said that indexing into a linked list isn't the most efficient way to access elements. In this loop, we're accessing 2 elements by index for each iteration of the loop. Let's try another method, this time using the for each loop. I'm going to copy and paste this method, renaming it to print itinerary 2. And I'm going to remove the code for the traditional for loop. Now I'll add the enhanced for loop, string previous town equals list.getFirst, traverse through all list elements, print where we are coming from and going to again, and update previous town. Okay, so I first set up previous town to be the first place in our list, then I set up the for each loop. Then I am printing out the previous town and the current town. And finally, previous town gets set to the current loops town variable, ready for the next loop. And that's it. I'll call this method now in the main method. I'll just change the existing call to the new method. So this code is more efficient. However, it prints out from Alice Springs to Alice Springs on that second line of output. Using this loop limits us to looping through the elements one at a time from the very first to the last. The traditional for loop is much more flexible if we don't want to loop through every element one at a time. But now I want to show you another way to do this without using either type of for loop. I'll copy and paste this method, print itinerary 2, and rename it to print itinerary 3. Now we're going to use something called a list iterator. I'll change some code in this method now. I'll start by defining a list iterator of type string called iterator and assign it list.listIterator. I'll change this to a while loop using iterator.hasNext. varTown equals iterator.next. Here, I've made 3 changes. I've set up a local variable with a type of list iterator of type string. And I've named it iterator and assigned it to a method on linked list called listIterator. After this, I changed the for loop to a while loop. I'm using a method on listIterator called hasNext, which will return true if there are more elements to process. After this, I have a local loop variable, which I'm calling town again, and setting this to the value returned from iterator.next, and instead of calling print itinerary 2, I'll call print itinerary 3. Let's see what this produces. We get the same output as before, including that problematic second line of output that we don't really want. Let's make one change to this print itinerary 3 method to fix that. When I make that call to the method list iterator on the linked list, I'll instead call an overloaded version passing the index of the first element I want to process. And now I'll run this again. And that problem is now resolved. You may be thinking, what's an iterator or what's a list iterator to be more specific? I'm going to end this video here and answer that question in the next video.